Oh, hi. In this video, we are going to look at the energy changes in a gravitational field and also how energy changes a different position in a vertical circular motion. So if there is a ball that is at, that is located at this particular position and as it is allowed to roll down, it will go along here. It will go through inside this vertical path, go along there, and this one. So let's look at the energies at different points. So at this position, before it starts moving, it will only have gravitational potential energy. As it comes down, gravitational potential energy will be changing into kinetic energy. So somewhere here, right at the very bottom, all its energy will be in kinetic energy format. And as long as there are no friction forces involved, kinetic energy over here will be equal to the gravitational potential energy there. As the ball rolls up, then at this position, it will have some gravitational potential energy. And because it is moving, it will have kinetic energy also. Now, to find out the speed at this particular point, now object must have enough speed to maintain this vertical motion. So in these type of questions, quite often we will be asked that at what height should the ball be released so that it is able to maintain this vertical circular motion inside this loop. So first of all, we need to calculate the minimum speed at this particular position. So the ball have a minimum speed, and at minimum speed, the support force is zero, only force is the gravity force, which is mg, and that will be supplying the centripetal force. So if we equate those equations, mg equals mv square over r, minimum speed comes out equal to gr. So that's the first step to calculate the speed. Once we have calculated the speed, we can calculate the kinetic energy at this position by using half mv square. And then motion, radius of the motion is from here to there, so total height will be twice more. Then you can calculate the gravitational potential energy by using this formula. So at this particular position at minimum speed, total energy over here will be gravitational energy plus kinetic energy, and this energy must be equal to the gravitational potential energy over here. So by equating these two energies equal to the total energy, we can calculate the height, minimum height from where the ball should be released so that it is able to maintain this vertical loop. So that's this part. Let's look at a little bit more into when the ball rolls up the hill. And again, if you look at this, is like making a vertical loop. So over here, what will be the forces? There will be a gravity force downwards and there will be support force upwards. Now, because it is making, this is part of a vertical loop, so there should be a force, centripetal force, which is towards the center of which is downwards. That means gravity cannot change. That means upward force, support force will be less than the gravity force. And what will be the unbalanced force or centripetal force? So that will be downwards, and that will be Fg minus the support force. And by using that calculation, we can calculate the speed. Now, in the revision sheet that you're working on, question 8 is like this situation where a toy car moving along here makes a vertical loop like this one. So everything will be still the same. Total energy is not gravitational potential energy, it's all in the kinetic energy format, which remains constant as there's no friction forces here. And as the ball moves up, over here, it will have both gravitational and kinetic energy. To solve these problems, again, it will be the similar reasoning that we used for this example. So using that one, you should be able to do this question. So that's all for this video. Thank you for watching it.